Good morning, friends. Today we have reached to the third series for SF and BM diagrams. Up till now in the previous lectures, we have discussed how to plot shear force and bending moment diagrams specifically for simply supported beam and cantilever beam. Now, today onwards, we are going to discuss for the overhanging beam, how to plot shear force diagram and how to plot bending moment diagram. So the main objectives of the today's session is to understand the concept of shear force and the bending moment, to plot the shear force diagram and bending moment diagram for overhanging beams. Before we proceed further, we do certain revision part, that is what is shear force, what is bending moment, and how to plot shear force and bending moment diagram. Let us we revise the basic concepts. Let us we go ahead. What is shear force and bending moment? First, when a beam is loaded by forces or couples, stresses and strains are created throughout the interior of the beam. These internal quantities are referred as shear force and bending moment. Let us be understood with this concept. Please refer the figure. Here in this particular figure, a beam which has been given to you with external loadings applied over here. Now, let us we take a section over here. Because of this section, my beam which has been divided into two parts, left part and right part. So just visualize, when I will take an individual free body diagram of a left part, see these two quantities, this force and this moment. This force is referred as shear force and this moment is referred as bending moment, and our intention in this particular series is to find out the shear force and bending moment for a particular given beam, specifically the overhanging beam. Now, what is shear force? Shear force is defined as the algebraic sum of all the vertical forces acting to the left or right of a section along the span of the beam. Repeat the word, algebraic sum of all the vertical forces. What is bending moment? It is the algebraic sum of all the moment of forces to the left or right of the section. And we have understood these two definitions very precisely up till now in the previous lectures. Now, sign convention. Sign convention for shear force and bending moment. This is a beam which has been given to us. Let us take a section over here. Then, section left upward force or section right downward force treated as positive. This is my sign convention, and with this my sign convention I am taking this as a positive shear force. Opposite to that, section left downward or section right upward, which is taken as negative shear force. Now for bending moment, section left clockwise or right anti-clockwise created a sagging nature of moment treated as positive bending moment. Vice versa, section left anti-clockwise or right clockwise creates a overturning that creates hogging moment. It is to be referred as negative bending moment. You can take the vice versa also. Now this is the procedure how to find out the shear force and bending moment at a particular section and how to plot shear force and bending moment diagrams. So step number 1 is to find out the reactions. Yes, this step number 1 is very much important for us to find out the reactions, because the reaction which has been found out with the help of the equilibrium conditions, The equilibrium conditions are sigma h is equal to 0, sigma v is equal to 0 and sigma m is equal to 0. Step number 2, cut the beam at a section, cross sections, and draw free body diagram of one piece of the beam. Now set up the equations. When we cut a beam, we have to take an individual section of a beam, either left part or either right part, and then we have to set up the equations for the same. Number 4, solve the shear force and bending moment at that cross section, and then we have to draw shear force and bending moment diagrams. So with this, let us we go ahead with our first problem, and let us be understood the concept how to plot the shear force and bending moment diagram for a given particular beam. Now this is example number 1. See the kind of beam which has been given to us. The beam holds one end or both the end projected beyond the support. This is my support. This part is projected beyond the support. This beam is referred as one-way overhanging beam. This beam is subjected to a single simple point load W at the tip at the free end. The span between two supports is L and the overhanging projections having a span is of length A. And our intention is to plot shear force and bending moment diagram for a given particular beam with the given loading. Step number 1, as usual, find out the support reactions. As we know the method to find out the support reaction, that is the equilibrium method, that is the step number 1. Sigma h is equal to 0. What is sigma h? Sum of all the horizontal forces are equated with 0. Here in this system, only RAH is acting over here, that is the reaction generated at A, not a single external force is acting on this particular body, means RAH is equal to 0. Second step, sigma V is equal to 0. Sigma is the symbolic representation of summation. Sigma V, sum of all the vertical component of forces are treated as 0. So the first force RAV plus RB, assuming upward forces are positive, is equal to W. So RAV plus RB is equal to W. We got an equation. In these equations there are two unknowns, RAV and RB. It is not possible for me or you to find out these two unknowns with the single equations. We need certain extra equations. We need certain extra condition to find out these two unknowns. So now let us use another equilibrium condition. Sigma MA is equal to 0 or sigma MB is equal to 0. Right now let us take sigma MB is equal to 0. Summation of all the moments of forces at B are equated with 0. Now first force, that is the RAV. Obviously RAH is 0. So the moment because of RAH over here is 0. Now RAV, that creates the moment RAV into L, creates a clockwise moment. Clockwise is taken as positive, so RAV into L. Another force is RB, but we have taken the moment over here, excuse me, we have taken a moment over here itself. So RB into 0 is 0. Now this W creates a moment once again clockwise, so positive W into A is equated with 0. So we got RAV is equal to minus WA by L. What is this minus sign suggest? Minus sign suggests that our assumed direction of RAV upward is wrong. RAV is acting downward of WA by L. Next are how to find out this RB. Let us put the value of RAV in this equation, and we got RB as W plus WA by L, and that is W bracket 1 plus A by L plus positive sign, means this direction is right. So now once these reactions are known with us, our intention is to plot or to find out the shear force at various sections. So let us go ahead over here on this tabletop. Place tabletop. The beam which has been given to us, overhanging beam, L is the span, A is the span over here, W is the point load which is acting over here. This reaction which is acting downward, WA over L, and this reaction is 1 plus A by L into W. This is my RB, this is the RA. And our intention is to plot shear force diagram with our sign convention: section left upward or right downward treated as positive. This is our sign convention. Now starting from this left support, taking a section over here. So my beam which has been divided into two parts, left part, right part. Let us take left part. What happens we will see. Section, left part, WA by L. This distance is of x. What is definition of shear force? Shear force is defined as algebraic sum of the forces. Now in this system only single force is acting, WA by L. So shear force at xx is equal to WA over L. Next question may arise about the sign conventions, plus or minus. So you just visualize section, left downward, opposite to that. Now it is look like this: section, left downward. This treated as negative. So this is negative. So shear force at section xx is WA by L. Now you just visualize from this point, from A point to B point, there is not a single load is applied, means this shear force xx is applicable between A and B. As such, there is no load is applied between A and B. Means as this is my baseline, all the negatives value are below baseline. So WA over L, that remains constant throughout up till the B point which has been reached. When we go or we will cross the B, we have to take another section over here. So my beam is look like this: one support, this is downward, another support over here, and this is my section xx. And what is the shear force at xx? Is equal to section left downward minus WA by L plus this is upward, W bracket 1 plus A by L, and VHU it is plus W. So now you can visualize between, now see the figure over here, between B and C, C that is the free end, between B and C there is no load and the shear force having a value constant W. So at this point my shear force suddenly changes from minus WA by L to plus W, remaining constant up to the point C, and VHU my shear force diagram. I wish now it will be clear. That is how to plot the shear force diagram. Now see the nature of shear force diagram and try to recall the points which has been taught to you in the previous classes, in the previous lectures. First, reaction itself gives us the value of shear force at that point. Second, between 2 point load, if there is no load, the variation of shear force which has been given by horizontal straight line. At a point load, the shear force suddenly changes over here, over here, over here. So the same rule, the rule which we have been taught in the previous various lectures in case of simply supported beam as well as in case of overhanging beam, we can apply over here right now also. So now see this PPT, the same thing we have been obtained over here, and this is our shear force diagram. Now I think you have understood very clearly how to plot shear force diagram. Let us proceed further for the bending moment. Over here on the tabletop, please. Now our next aim is to plot bending moment diagram. Procedures remain same, that is, we have to take the sections. Now let us take a section over here, section XX, and the figure is there with us. This is the important lines where the loads are acting, and this is the basic baseline. All the positive values above baseline, all the negative value below baseline. Now we have to take the bending moment at XX in this region. This is our basic section XX, and its left part is equal to WA by L, because single force is there, multiply by X. And what is the sign convention? This is the force multiplied by distance is nothing the moment, and algebraic sum of the moments to the left are known as the bending moment, that we have been found out because the single force is acting. Now the sign convention, section left create anti-clockwise moment, means section left anti-clockwise. This is nothing but hogging nature, and it has been treated as negative as per our sign convention. Minus sign is there.